Yeah, well, what I'm going to talk about today is about bridges, not necessarily L1 to L2 bridge, but like any bridge. Who we are ChainSecurity. It's a company that specializes on security audits and some security tooling. So what we are mostly trying to find in client's code is that contracts are solvent, meaning that if money goes in, the contract always has the ability to give it out to people eventually. So no value is lost. Yeah, we worked on many instances where we actually found bugs not in a smart contract. Like I think we had top 3 in the Ethereum bounties overall, just because we fortunately or unfortunately found some bugs even in the Ethereum nodes. And regarding L2, yeah, we have some history of auditing bridge implementations and even applications that rely on bridges. For example, we reviewed DAI Optimism implementation, or yeah, that's run on Optimism. Yeah, it's shortly what we've done. So today I want to speak about bridges and say that there are some problems with them, definitely, that we have in the field, that we are probably not paying enough attention to security of such critical pieces of infrastructure that's generally used everywhere. So on the right side, you see, who doesn't know, it's Rect Board. It's a website that basically lists all hacks that happen to Web3 protocols, and it's sorted usually by the total value lost. So if you look at here, yeah, there's top 12 places, but yeah, top 3 of them are bridges. This is unfortunate, and on the left side there's some motivation why this problem occur. Like, first of all, it's many protocols use same bridge, so bridge is basically a central point of failure, and because it holds so many funds, finding a problem or a bug in bridge for attacker basically means draining completely like a lot of money. Yeah, you see, it's numbers are crazy. This is 9-digit numbers for all these 3 bridges that were lost. And also another problem is that there's no bridge standard. Like we have ERC20 standard, and most ERC20s behave somewhat similarly. But for bridges, if I start using Polygon bridges, this is one implementation. If I want to use Optimist bridges, it's differently other implementation, right? This all ends up as a huge pressure on DeFi developers and developers who want to integrate with the bridge, right? And that's unfortunately leads to a lot of human errors and problems with the software. Yeah, another thing is that if the bridge connects 2 chains, right, and both chains are not in general equal. There is some security guarantees that can be on one chain, but they can be completely absent on one chain. Yes. For a good example is like Gnosis chain. Who doesn't know, like if you're bridging a token to on Gnosis, all bridged Gnosis tokens have reentrancy built in by default. It's from a security perspective a huge another problem, but this is
fixing that today, by the way.
Could be, yeah, but could be, yeah. It's I think we learned it hard way. There was a hack connected to this, and yeah, I don't blame Gnosis. I honestly just say that its problem comes that developers who were building, I think this was an Agave problem, like with exactly that you mentioned, it's, where they forked Aave on Gnosis chain, but Aave initially doesn't work with reentrant tokens. But on Gnosis chain, it resulted in a problem. So yeah, and yeah, fourth problem is the overall problem, not even like for bridges, but for bridges it's even more a problem to deal with. It's not all tokens are the same. There is a rebalancing tokens, tokens that give yields, right? There is tokens that do whatever sort of things tokens can do, like USDT, or tokens with double entry points. So I'm gonna mention this later. But yeah, this is a problem. And another thing is, I'm not. This is kind of comes from the regular bridges that rely on validator set. That's basically there is always some sort of a signature verification to actually show that the transaction comes from a validator or from the like scheduler, right, sequencer. So it's basically a conceptual problem that maintaining a hot wallet is hard. It's like usually all exchanges, centralized exchanges, try to limit the exposure of hot wallet to the funds, right? But for the bridge case, it's almost impossible to do because you basically always need to have access to all keys that basically responsible for all the money the bridge holds, right? And another point is like UX features. Like people always want the most easy way to deal with bridge, right? You want to click button on the website and it must go through smooth on the other side, right? But if you think about technical problems that the bridge architects and bridge developers need to deal with when doing this, for example, transactions can run out on other side of a bridge, right? Then you basically need to deal with this out of gas exceptions, and it's already just this basic feature that brings a lot of complexity to the implementation of bridge itself. Yeah. So so what is this bridge? This is a most generic bridge. Yeah, in the center you see like a validators, but you can replace it like with a sequencer for like optimist kind of bridge. The basic thing the bridge does, it just relays a message or transaction in this case. User comes with his transaction, he speaks to the smart contract on the like blue chain. This smart contract usually emits an event that's picked up by the validator or sequencer. And on the other side, we are, because the validators is authorized to relay messages, they speak to the other side of a bridge and the transaction eventually gets sent, right? This is a most generic type of bridge. It's quite, doesn't say much about the ERC20s or so. For like actual relaying of ERC20, things become even more complex. For example, the bridge needs to transfer tokens from user when it sees that the user sends a deposit transaction. Again, we have the same event emission. Validators needs to pick it up, put it on the other side, and on the other side we are minting the basically representation of that token, right? So that's how kind of tokens are related. They actually never leave the blue chain, right? They are basically locked there, and their representation is emitted on the other side of a bridge. So I just want to now look at validators. What's their, in these two basic scenarios, what their basic role is. They need to listen to events, they need to sign transactions for relaying, and their signatures need to be verified to confirm transaction validity, right? This seems simple, right, to do, but if we look at each of these points, there is a history shows that problems arose. For example, this is 6 lines of code, literally, that stole $1 million. If you see, this was just a contract that here emits some event, right? And I can show the names of chains that got hacked like this. I think it was Sense and Sora that basically were exposed to this bug. So in a regular deposit, a user would just come and speak to the bridge contract, and event would be emitted. But how these 6 lines of code were used in the reality is that user came, speak to the side of contract that resulted in withdrawal events. This was a legit event, but during the withdrawal, user actually gets a control over the call and emits his own event. And because the validator node, the validator software was filtering events wrong way, this deposit was picked up as a legit deposit that was done on behalf of user. So yeah, and this is basically the first point how even listening to events is not easy. It sounds easy, but it's not. Other 2 points, yeah, I kind of group them together. And here I want to come back to our top 3 hacks. They basically all related to those 2 problems. That's signing transactions for relaying and verification of signatures is also something that's really hard on architecture design. It sounds easy, like you just take signatures, verify them, right? But in reality, yeah, all those 3 hacks that occurred, they had a lot of skillful developers that had a lot of like technical expertise in the field, but still such issues arose where, yeah, running network, I think this was the Axie Infinity kind of problem where basically one party managed to get the control over the validator set, and they were able to basically sign the transactions that shouldn't have been signed, right? Poly network, this was a bit not related to the signature, but still related because they basically the bridge contract was authorized. As you saw, like bridge contract can execute any transaction on behalf of a user as long as it saw that it comes from the other side of a chain, right? And in that case, basically, the bridge side contract had rights on other contracts of the chain. These rights were blocked by certain functions. It's, for example, but this check that this function shouldn't be called were done wrong way. And yeah, another is a wormhole. It's also the complexity of wormhole hack comes from that it was a bridge between Ethereum and Solana. And the problem arose not on the Ethereum side, but on the Solana side, where they had a basically problem with their default library for signature checks, where basically signatures were not checked for certain conditions, and hacker managed to exactly meet those conditions with his transaction and hack the money. Yeah. Regarding the tokens, I think this is a problem not only with bridges, but with any DeFi, with any contract that tries to aggregate and use other tokens as underlying or as a collateral. So tokens can have callbacks. This is really low-level detail that brings huge security problems. The callback is something that basically allows any party to, at some point during the transaction flow, execute their own code. And in general, this is problematic from security perspective because quite often developers forget that the flow of transaction execution will be handed to third party, and they leave the contract in a not kind of finalized state. All right. Another problem is like inflating, deflating tokens. So, for example, imagine we are bridging a token that the value of this token will grow on the one side of a bridge, right? So it's easy to do it on a deposit, but on a withdrawal, you basically need to, for each user who deposited, look at which point of time he deposited and how much his amount of bridged money was kind of inflated with time, right? It becomes really complex from token bridge perspective to accommodate for all these small cases. Another point is like tokens can have multiple entry points, which basically, yeah, it's a small detail that recently even caused some problem with the compound. It's the USDT token had basically two addresses, and calling any of this address will result on a transfer of USDT funds. So all these small details needs to be basically Yeah. Actually, there's 2 times USDT mentioned because USDT also does one dirty thing that they don't return the return data, and that's why people who maybe more technical know that's why safe transfer exists in Open Zeppelin libraries. Yeah. There is a there's a huge list of such tokens. That's I leave a link here. That all developers who, no matter what they deal with bridges or just any DeFi protocol, needs to be aware about. Yep. So now I'm going to speak about something like slow bridges, because this validator set we saw, it's kind of considered a trust-based bridge, and they're like if you do the optimism bridge, right? There is faster bridges that will be available soon, but there is a default bridge that's available, and it's based on rollups, right? And yeah, it's quite fast to relay from L1 to L2, but on the other way, you need to wait some time, right? You need to have 1 week of this dispute time where your transaction can fail. And this challenge period is something that brings complexity. Like if we look at validators are nodes, and this complexity basically of when to relay transaction lies in node implementation. But now with this challenge period for this bridges that are utilizing rollups, this complexity needs to live not on the node level, but it needs to live on the smart contract level. This is basically where complexity migrates from centralized nodes of software that's run by validators to like more decentralized smart contract, right? But this is the result, again, in a huge complexity increase, because validation of correctness needs to be done now on-chain, right? Not like off-chain. And off-chain, meaning on the validator side, right? Meaning that will result even in more complex bridge contracts. And I honestly want to say that all people who want to do such bridges need to be really, really careful about their security, because it's a huge security. From security perspective, is a point of failure that's really hard to implement right. Yeah, something else to know about this challenge period is the finality of transaction also becomes not as it used to be when you were relaying with the validator set. That's because you always need to be aware that a transaction can be reverted on L2 for like this dispute period as well, right? So that means you shouldn't rely. Yeah, it's basically same to that you have different security guarantees on both chains, right? So this is a point developers need to remember. Yeah, this is a fourth point about trust, but hard to upgrade. Exactly comes from the fact that it's quite easy to update the validators, right? You basically probably know all the parties that are involved in the validation, but updating the token bridge contract, it's much harder, and usually it needs to pass some on-chain voting, because you basically need to replace the contract, and it's harder than replacing the validator. If we have like a Solana history, look at Solana, they had a history of silently updating validators like overnight, and it didn't result in any breaking changes, right? But updating smart contracts that do the bridging of assets, it won't be that smooth, and it could cause more problems, because then you basically have upgradable bridge contracts that's again security risk. Yeah. So a summary, that's we as a security company that cares about people not losing their money. Bridge developers really need to be careful about architecture. They need to think good about what are the smart contracts they are doing that need to be really good tested. They also need to put effort into thinking, designing, and distributing keys in the right way. They need to monitor the chain actively for like correct event emissions. They also need to monitor the status, because quite often, because of this dispute period, the hack can be prevented if you know that something bad is coming, right? So this is kind of a last point of failure for your security process, where you're doing basically not proactive measures but active measures. It's monitoring, and quite often bridges and are getting updates, and this is a huge challenge from developer perspective to come up with a good model that allows you to ship new features but maintain the security, because without a good processes in place, you are really risking basically removing all security from your protocol slowly by bringing more and more features. And two features separately can be safe, but the combination can result in a money loss and hacks. And for people who are planning to work with bridges, they basically want to use bridge as part of their protocol flow. They first need to learn how to use bridges. This means that you need to really carefully study the documentation, and in most cases, honestly, it's not enough. You also actually need to dive into the bare bone, like a smart contract of the bridge implementation, to see what's happening under the hood. Things that like Solidity is not that yet huge smart contracts. So if you're a developer, please go under the hood and study it well, because quite often documentation can be stale or not precise, right? And you also need to be, in addition to knowing the bridge implementation itself, know what the chains offer, right? What, for example, on Ethereum, it's quite hard to do those attacks, right? The gas is expensive. You're probably not going to see people intentionally growing the size of your arrays, right? But that's something that easily can happen on chains with cheaper gas and cheaper transactions, right? People can do it just for sake of blocking your contract, and that's not something you would do. Yeah. So, yep, that's the end of my talk. And yeah, I guess.
We have time for one quick question.
I can promise it's one question, but yeah, thanks for the talk. It's a very important topic, because on one side, you know, when you have a bridge and one piece of the liquidity on one side is missing, then you get into very big problems in terms of liquidity on the chain. So I've got two questions. First off, do you think that there's room for zero-knowledge proofs to make bridging better, more trustless, where you say, okay, I've done a certain action, I've deposited a certain amount of money on one side, here's a proof that I actually have it on that side. Do you think that zero-knowledge proofs there can be a big improvement for trustlessness of bridges? And the second question is, do you think that these issues that exist with current blockchains are mostly there because Ethereum doesn't really have a way to communicate outside of itself, like, for instance, Cosmos has with IBC?
So for the first question, we thought about this zero-knowledge safety, right? And honestly, it's a hard topic, because from security perspective, it's also hard to even see that you was hacked, right? Because you don't see inside the hood, right? And if attacker doesn't drain your contract overnight and do it slowly, it's exactly monitoring perspective really hard to detect such attacks. Speaking about security itself that zero knowledge can bring, that's a good question, because my opinion is that human mistakes are possible everywhere, and if we're doing them on a smart contract, to do the same kind of mistakes but on a circuit level of zero knowledge proofs, right? It's completely possible, and yeah, ideally we will need to do again like security audits of the zero knowledge circuits. We will need to do probably ideally formal verify them. That's only good states are possible, but from this perspective, I think most of the bugs comes from human error or misunderstanding, and zero knowledge are not that they're bringing other types of security, like consensus level securities, but not this type of like simple bug security. For the second question, what was it about? That's a communication
outside of the chain.
Outside of chain, so yeah.
Cosmos with IBC, whether that will make it more easy to do bridging.
Good question. I think a good example of more secure bridge practices is something Near does, where basically they are having a light client of Ethereum attached, and they basically it's sort of validator set is decentralized. It's basically everyone is decentralized. So if when optimism comes to the decentralized sequencer, that's be a good improvement of security as well, in my opinion.
Okay, thank you.